This is the second section of chapter 2, allocation problems, and this section is on using a dummy. Now we need to use a dummy, a worker or a dummy task if the number of workers is not equal to the number of tasks. So we might have more workers than tasks or more tasks than workers. You'll know this because the number of rows and columns n and m will not be equal, so we'll have a non-square matrix. Now if we have the number of workers in a row or a number of tasks in a column, we'll need to add either an extra row or column, and we use D for dummy. So this is going to be like a dummy worker or a dummy tasks. So we still may need to allocate a dummy worker to a task or a worker to a dummy task. And what we do is we either fill that row or column with zeros. So the dummy task or dummy worker is going to be a row or column filled with zeros. And since we will have a row or column filled with zeros, we can skip either row or column reduction based on whether it's a column filled with zeros, so like a dummy task, or a row filled with zeros, like a dummy worker. So one of those steps we'll be able to skip, and you'll see it when you do a question. Example 4. The table shows the time in minutes taken for 4 workers, Mark, Nikki, Nigel and Susie, to do each of 3 tasks A, B and C. Use the Hungarian algorithm to obtain an allocation that minimizes the total time. Okay, well, you can see 4 workers, 3 tasks. I'm going to need a dummy task. So we've got tasks A, B, C and D. A, B and C and D. So D, that's my dummy task, that's handy, D for dummy. And then we've got Mark, Nikki, Nigel and Susie. So we know in the dummy column we're going to have zeros. And we'll put our other costs in: 12, 23, 15, 14, 21, 17, 13, 22, 20, 14, 24 and 13. And you can see that every row has a 0 in because they're dummy, so we can skip row reduction and just go straight on to the column reduction. So we're looking for the smallest value in every column. So first column smallest value is 12, so we're going to take 12 away from each of those column values, then 21 and then 13. Right, so taking away 12 from each value in the first column, we'll have 0, 2, 1, 2. Taking away 21 from each of the values in the second column, 2, 0, 1, 2. And taking away 13 from each of the values in the third column, we have 2, 4, 7, 0. Let's see how many lines we need to cover all the zeros. So let's cover all 4 of those with 1 line. Now, because there's zeros in each row, I need to use 3 more lines. So this means I've found an optimal solution. Right, so let's see who we need to allocate to different tasks. Oh, so Mark, single 0 in that column. So Mark, we're going to allocate to task A, and that comes at a cost of 12 minutes. So let's scrub him out of the table. Mark is gone, task A is gone. If I look at the second column here, single 0 here, so Nikki must be allocated to task B. So Nikki, task B, and that's going to be at a cost of 21 minutes. So we'll get rid of Nikki and task B. Then the next column, single 0 here, Susie to task C. Susie, task C. and that's going to be at a cost of 13 minutes. And Nigel gets off any work. He gets allocated to the dummy task, and that's at a cost of 0 minutes. So he gets the day off. So total cost is going to be 12 plus 21 plus 13, and that is 46 minutes. So you should now be able to do exercise 2B on pages 50 to 51 of the textbook.